centuries, rogue waves were dismissed as sailors' myths, impossible walls of water that science claimed simply couldn't exist. That changed in 1995 when an 84-foot monster hit the Draupner platform, proving the legends were real. But today, a much darker reality is emerging. These once-in-a-lifetime events are no longer rare. They are becoming more frequent, more powerful, and according to new data, they are growing larger every single year. The ocean is evolving, and the physics we've relied on for decades is breaking down. Today, we uncover why the world's most terrifying waves are getting even more dangerous. Welcome to Deep Current. For a long time, the danger of rogue waves was misunderstood. The old belief was simple. If a wave was extreme enough, it had to be a statistical fluke, a rare accident, a brief act of chaos in an otherwise predictable ocean. But modern measurements have forced scientists to rethink that assumption. The first major shock came with the Draupner wave in the North Sea. It was not a sailor's story. It was not a damaged memory. It was captured by instruments. A wave more than twice the height of the surrounding sea slammed into the platform, and from that moment on, rogue waves moved from folklore into hard science. Even NOAA now defines rogue waves as waves at least twice the height of surrounding waves and describes them as steep, unexpected walls of water. But the real turning point came later. Once researchers began collecting larger datasets from buoys, platforms, and satellite observations, it became clear that rogue waves were not just real. They were more common, more variable, and more regionally sensitive than older wave models had assumed. Studies using large real-world datasets found that the ocean does not produce rogue waves only through one exotic mechanism. In many cases, they form through the alignment and focusing of ordinary waves under the right sea state conditions, with non-linear effects, sharpening the danger even further. That matters because it changes the whole psychological meaning of the threat. If rogue waves required some once-in-a-century impossible setup, then they would remain terrifying but distant. But if they can emerge from ordinary ocean physics more often than expected, then they are not anomalies in the usual sense. They are part of the ocean's real behavior. And now, scientists are finding reasons to believe that behavior is becoming more dangerous. The first reason is exposure. The modern ocean is crowded with more infrastructure than ever before. Container ships, offshore platforms, wind installations, research stations, energy corridors, and high-value shipping routes now operate in regions where extreme waves can do catastrophic damage. A rogue wave does not need to be globally more common to become a bigger threat. It only has to hit a busier ocean, and the ocean today is busier than the one that produced the old legends. The second reason is that in some regions, rogue waves appear to be getting more severe relative to the surrounding sea state. That distinction is important. A 2019 study analyzing wave buoy data along the U.S. West Coast found that while there was no broad trend in absolute rogue wave height, some locations showed rogue waves getting larger relative to background significant wave height. In other words, the most dangerous waves were becoming more disproportionate compared with the seas around them. That makes them harder to anticipate operationally and potentially more damaging to ships and offshore structures designed around broader sea state expectations. The same study also found that rogue waves were more prevalent and more severe in winter. That is a subtle point, but a critical one. A rogue wave is terrifying not just because it is tall. It is terrifying because it breaks the pattern. A vessel may be riding through dangerous but manageable seas, and then one wave arrives that is wildly out of scale with everything around it. If those extremes are becoming more pronounced relative to the surrounding wave field in some regions, then the danger is not just physical, it is operational. It undermines prediction, judgment, and design assumptions. And that brings us to the third reason rogue waves are becoming more dangerous. Forecasting still lags behind reality. For decades, scientists searched for reliable indicators that could signal rogue wave danger in advance, but real-world studies have repeatedly challenged many of the traditional parameters researchers expected to be most predictive. A 2021 analysis using more than 1 billion observed waves found that several favored theoretical indicators were weak predictors in practical settings. Instead, other sea-state relationships, especially crest-trough correlation, turned out to matter more. That means the science is improving, but it also means one uncomfortable truth remains. We still do not forecast rogue waves as confidently as we forecast many other ocean hazards. There has been progress. A 2024 study showed that machine learning systems trained on field buoy data could predict a substantial fraction of rogue waves up to a minute in advance, and in many cases, even several minutes ahead. That is a major advance. But it is not the same as mature, universal operational forecasting across the world's oceans. So right now, the danger sits in a troubling space. We know rogue waves are real. We know they are not as impossibly rare as once believed. We know some regions show intensification relative to background conditions. We know sea state structure matters deeply, and we know forecasting remains incomplete. That combination is exactly what makes a hazard more dangerous in the real world. Then there is the climate question. This is where the story becomes more complicated and more serious. Scientists are still careful about making broad claims that climate change is causing rogue waves everywhere to become taller in absolute terms. The evidence is not that simple, but climate change is altering the ocean in ways that absolutely matter for extreme wave risk. It is changing storm behavior, shifting wind patterns, affecting wave climates, and increasing the exposure of coastal and offshore infrastructure to extreme marine events. Rogue waves do not happen in isolation from the larger sea state. If storm tracks, seasonal intensity, and background wave conditions change, then the environments that support rogue wave formation can change too. This is why the older wave physics feels less secure than it once did, not because the laws of motion are collapsing, but because the ocean system those laws act within is shifting. A changing ocean means changing combinations of wind, swell direction, current interaction, and wave grouping, and rogue waves are born in combinations. Recent work has also challenged some of the older assumptions about how these waves form. A 2025 study using long-term North Sea laser altimeter records argued that third-order modulational instability, long treated as a major explanation in some settings, did not significantly drive the largest measured waves there. Instead, second-order bound wave effects and constructive focusing were more important. In plain language, rogue waves may not require exotic physics nearly as often as people thought. They may emerge from familiar wave systems aligning in the worst possible way. That makes them more dangerous, not less, because if an extreme threat depends on rare, highly unusual physics, it stays narrow. If it depends on ordinary ocean ingredients arranging themselves correctly, then the threat lives much closer to normal weather than people are comfortable admitting. And that is exactly where rogue waves now seem to sit. Close enough to normal ocean dynamics to remain hard to isolate. Extreme enough to destroy ships, platforms, and coastal systems when they appear. There is also another reason they feel more dangerous now. We are finally measuring them properly. For much of maritime history, ships encountered rogue waves alone. No buoy, no laser platform, no satellite confirmation, no machine learning reconstruction afterward. Now, with better observation systems, the ocean is revealing how often these events may occur and how much hidden structure exists inside storm seas. Some of what looks like an increase in danger is also an increase in honesty. We are no longer blind in the way earlier generations were, but improved observation does not reduce the threat. It reveals it, and when the data finally becomes good enough, the old comforting assumptions begin to fail. That is why rogue waves feel more dangerous today than they did even 20 years ago. Not because we suddenly became dramatic, not because sailors exaggerated, but because the science has caught up far enough to show us that the ocean's most violent surprises are not outside the system. They are part of it. The sea has always been capable of focusing its energy into a single, steep, punishing wall of water. What is changing now is our understanding of where, when, and how often that can happen. and how exposed the modern world has become to those moments. Rogue waves are no longer just legends confirmed by one famous impact in 1995. They are a measurable hazard in a changing ocean, a risk to shipping lanes, a risk to offshore infrastructure, a risk to coastal systems, and a reminder that even now, with modern science, there are still places where the ocean can exceed the models we trust most. The terrifying truth is not that rogue waves are impossible, it is that they are natural. And in a world of shifting storms, changing seas, and expanding human activity across the ocean, natural may be more dangerous than impossible ever was.